Greetings. Welcome back. If you're a returning viewer, welcome. If you are a new viewer, so we have one segment planned here, but it's actually got two parts. It's the redefinition of Setq. Setq was covered in one of the earlier episodes, but it's your basic way of defining variables. Set q x to 100. So that's how you define variables in Lisp, or change their value. One of you out there might remember that I said that setq had to be a special form. A special form is a function that does something special with its arguments rather than evaluate them in left to right order. This was all covered previously, so if you're lost, go back and watch some of the earlier episodes and we'll cover it in more detail. One thing I was thinking about today was that I actually have setq as a form, a special form in Sigil, the Lisp that Skynet is built out of, which to me is wrong, because we can redefine setq actually as a macro outside of the Lisp. What's the difference, you say? Well, the whole point of this exercise of writing Skynet is to actually pare down the Lisp to as small a unit as possible to build the Lisp on top of. So basically we're creating, in mathematical terms, a set of axioms that a Lisp is going to get built out of. And one thing that you do when you're working with axioms is you always try and get rid of them. So the less axioms, the better. So we're going to remove setq as an axiom or special form or built-in, and we're going to replace it with a macro. And really, you shouldn't be using setq anyways. You should be using setf, which we might also fix to work in a general purpose way. Setf is the modern way of setting variables in the Lisp world, at least in the common Lisp world. But setq is still around for legacy reasons. So since we're starting fresh and starting new, we're going to remove setq and simply use setf to define and set our variables. Pretty cool, huh? I think so. So the first thing we're going to do is we're going to remove setq. So if we look here, actually the first thing we're going to do is remove setq from the documentation so that we don't forget about it and make people think it's a default built-in. With that done, we're now going to find setq code. This here is one of the internal functions of Sigil. It's called a val. It's one of the primitives. It's defined in the McCarthy paper, I think. I'm pretty sure. It's kind of important. Inside setq, we actually have to special case all of our special forms. Here we have setq, and we're just going to get rid of it. Boom. That was easy. We're also going to fix setf to handle general purpose setting like setq used to do. Isn't that cheating? No. So the code from setq doesn't evaluate the first argument, just like we know. And it does evaluate the second argument, which is why it used to be a special form. I'm not rushing, but I'm doing 2 changes at once, which in JavaScript, not so good of an idea. I tend to iterate really quickly and try and refresh and reload all my code on every single small, tiny, no matter how small change, so that I make sure that I don't have to keep backtracking to previous places that I changed to find where I forgot a comma or something stupid. But we're going to risk it this time, because the first time was just a delete. So, how much do you want to bet this is going to work? So if we set qx to 1, that doesn't work because it isn't there anymore. If we set fx to 1, woohoo. Set fx to 1 works. So we have now gotten rid of setq. But I like setq, you say. I know setq. What the hell is setf? That's crazy talk. Okay. Part 2. We're now going to redefine setf as a macro, which is pretty important to pay attention to, because really in this Lisp, the only thing you can easily define is a macro. So this section is both an explanation of what a macro is. Some of that might go a bit over your head, but that's okay. And we're going to actually write a macro, and I'm going to explain it this time, unlike the previous episodes. So a macro. A macro is a function that doesn't evaluate its arguments, and it returns code that is then executed. So unlike a regular function, which does evaluate all its arguments and returns whatever you want, a macro doesn't evaluate its arguments and returns code that is then executed. A macro is defined with the symbol or the function, or actually special form, called def macro. So since a macro returns code, we better figure out what code we want to return. So if you remember from a previous video, setq actually is the same as set quote x to 1. I think this was covered in the second episode. So if we want to pretend like setq is still there, or redefine it, the code we want to execute is the second line. So like we say, we're going to define a macro. The first argument to def macro is the name of the macro. Then you do the arguments. So the arguments to setq are a symbol, s, and a value v. Feel free to call those symbol and value in your own version. I just prefer terseness sometimes. Now we get to the back quote. If you remember from a previous episode, we've already covered the idea of a single quote. The straight up quote to the right of your keyboard, right beside the enter key. We've covered single quoting, and that basically stops evaluation of whatever follows it. So now we have a back quote. That's on the top left-hand corner of your keyboard. And it also stops evaluation. What a back quote is technically called is a quasi-quote. That's where, if you remember from a previous episode, I was debating whether you would ever want to use quasi-quote in code that you write. I was debating that because there's already syntax for quasi-quoting that's far more convenient than actually writing out the simple Q quote. But basically, much like the single quote, the quasi-quote stops evaluation of whatever follows it. So, but it's special. Or else we'd just be using a single quote. At a basic level, at the macros that we're going to write for the next while, just remember that all macros bodies start with a quasi-quote. That's not true in more advanced macros, but in this case it does. Now, in Lisp, this statement of the body, since we're only going to have one line here, because we're only returning one line of code, is the thing that's returned and then executed. Lisp always returns the last statement of a function or a macro, or a lambda or a macro. That's just how it is. Kind of a functional programming thing. Every statement in Lisp returns a value. In this case of the macro, it's going to return a line of code. So we're going to just type out that code that we already decided. We're just going to put out exactly what we had there before. Astute viewers will notice that if I was to now define this variable and execute setq on the command line, let's just do that. But to make it more interesting, we're going to set the value to 2. So now we have a macro called setq. Let's try that. Let's try setting x to 3. Oh, it returned 2. That's interesting. Oh, so it actually set the value to 2, which is exactly what we told it to do. So that should be surprising to no one. Other than the fact that we just called a function and then ran some code. So now we're going to fix it to actually do what we want it to do. So now we've got basically the fourth element of syntax in Lisp, which is only important when you're inside a quasi-quote or back quote, is the comma. Since we're quoting and stopping evaluation of the list, everything inside of this list is also quoted. So sometimes what we want to do is actually evaluate things inside of lists, even though we're telling it not to be evaluated. So it's essentially, if you know anything about C, it's like dereferencing a pointer. A pointer is the address of something, and dereferencing that pointer says, give me what's at that address. So, comma, if I was to not put a comma here and just put an S, that's give me the address of S. Now, if I was to put comma S, that says give me what S contains. Give me the contents of S, or the value of S. So, hopefully that's kind of clear, but that's really the best way I can think of explaining it. What we want to do here inside this code that we're returning is literally insert the value of S that we are passing to setq when we call it. So maybe this will be a bit more clear. We're also going to put comma V here. So in the code, we now have inserted the value of S that we passed to setq and the value of V. So if we fill in the blanks, which is literally what comma S and comma V are doing, and we pass the value of X and the value of 3, comma S is going to be X, and comma V is going to be 3. So now we're going to run setq x3 again, and it returns 3, which is the value we have now set x2. So in case you're playing along at home, this is the code. Give it a shot. I'll be updating Skynet right after this to remove setq. So you're going to have to redefine it. And that's pretty much all I wanted to cover. So this basically, as an overview, was the deletion of setq. And the redefinition of setq is a macro, which is our first non-trivial macro. We'll cover more on macros in far greater detail in the future, because Sigil really only lets you define macros easily, syntactically. So we'll be covering them a huge amount, because, as I said, I think in the first episode, the only reason you use Lisp is because of macros. That's where the power comes from. And just to recap, if you already know this, you can stop now. If you don't know how to get to Skynet to try out this stuff that I'm typing out, you want to go to http://busfactor1.ca bin Skynet. Here you'll find the giant engage button, and by the time you see this video, the updated version will be there. And yeah, play along and tune in next time. And if you like the music, this actually isn't me. This is an album called VA RND, or actually no, the VA wasn't there. RND, some floating point number, and it's phenomenal. So if you like the music, that's where it came from this time. I didn't actually write this stuff. Probably why it's so good. So have a good night. Thanks for watching, and tune in next time.